Hey y'all, let's talk about section 2. Let me find it. Here we go. Section 2, we're talking about parametric functions modeling planar motion. So let's get into it. So remember, just like we learned you learned yesterday, that we have parametric equations where f of t, t is our input, our independent variable, where we have two outputs or dependent variables, x and y. This shows us how particle motion happens in the xy plane. So if we have a parametric function given here, where of course this first part is our x of t, and the second part here is your y of t, and we do have a restricted domain. So the domain of t is between -2 and 2. We're going to use the table, which they've already laid out for us here, to sketch the graph below. So let's go ahead and just quickly sketch these points. We know that these points are x comma y would be 0 comma -6. So that's 1, 2, 3, 4, 5, 6 on the y-axis. Down here, negative. +3, -3 is next. Then 0, 0. Then -3, up 3. And then 0, 6. So we could see a couple of different things. This could look like a zigzag. It could look like a curve. We're not really sure. We also see here that there's some more that we can do with it, because we see that this is a function that we're given. So if we really want to see what's going on here, we probably should look at some of the points that are in between where t is -2 and 1, in between -1 and 0, and so on. So the closer and closer we can get to some points in between, we can actually see what this graph is. So this is when your graphing calculator becomes incredibly helpful. So let's go ahead and look at your graphing calculators, okay? Hopefully, let's go ahead and make sure that your mode is in parametric, So go ahead and hit mode here. And as you can see, as I look down here, mine is already in parametric, but if yours was in function mode, just go ahead and put your cursor on parametric, hit enter, and then you're going to hit second quit out of that to get back to our regular screen. Now hit your y equals key, and this will tell you, hey, what kind of parametric equation do you want to input? Mine seems to have some problems here. Looking at this one. Okay, so let's look at this one again. This is our first equation here, where we're talking about, here it is. This t cubed minus 4t is your x of t. So that's what we're going to type in here. So we're going to go your variable key next to your alpha key. So when you hit the variable key, before it would pull up x for us, but now it pulls up t, okay? So we're going to say t cubed, so you go caret to the third, all minus, so hit to the right to get out of that exponent. You're going to go minus 4t, okay? Click down to get to your y1, and we're going to go 3t. So once we have that in, we can hit our window. So go ahead and hit window, and we can see our t minimum is 0, but remember, our restriction is actually from -2 to 2. So let's make sure that our t minimum is -2, our t maximum is 2, and our t step just tells me how many times do you want to evaluate a point. In our chart, we have evaluated them one at a time, but we want more of those values. So you can choose like 0.01, because we want to see what's happening in between. Our x min and x max are -10 and 10. That's great, because that's actually what we have on our graph. And our y min and y max are also -10, 10, which is also perfect because it's on our graph. If I hit graph now, we actually see that this graph, and it actually sketched it for you. We started from the bottom here, and we went up and over in a nice, cute curve, okay? I'm going to go over that and show the direction. So remember, we started here. We're going to put this on the graph this time, that we're showing the direction that it's going. Okay, we'll bring back the calculator in a little bit. So now that we're looking at that, if there was no restriction on the domain, so we're looking here, what would the position of the particle be at t equals 7? So since we know the function f of t, we know I can find f of 10 is going to be t cubed, that's 10 cubed, minus 4 times t, which is 10, comma 3t. Well, 3t is just 10, yes? So let's go ahead and evaluate this. I know 10 cubed is 1,000 minus 40. 1,000 minus 40 is 990, or 9,960, comma 3 times 10 is just 30. And this is our location if the particle was 10. So let's talk about some horizontal and vertical extrema. So before we talked about function extrema, maximums and minimums, but because we're talking about x and y functions of our parametrics, we know horizontal as left and right, that's for our x of t, and vertical is up and down, which is our y of t. So let's keep this in mind. The horizontal extrema of f of t occur at the maximum and minimum values of specifically x of t, which makes sense because we're looking at the horizontal movement. And the vertical extrema of f of t occurs at the maximum and minimum values of y of t. Again, this also makes sense because we're looking at that vertical. So let's practice this. So at f of t given here for this restriction, we're going to determine the horizontal extrema. So remember, again, we're going to be looking at this x of t. So can you kind of see what's happening here? So if I know how it moves left and right, but I want to know which one's the biggest, which one's the smallest, right? So I know, hey, well, x of t, so x of t is 1 minus t. If you can kind of visualize what this is going to look like, it's going to start at that 1, and then it's going to go down 1 over 1. This way from when x is negative 2 until x is 5, something like this, okay? So we can see here, because it's a negative slope, the highest it's going to be is on this point here when x is its least, or when t is its least value. So I can see on this interval, this is going to be the maximum, and this is going to be the minimum. So I can say at x of negative 2, actually put this in black, if x of negative 2, we will have a value of 1 minus negative 2, which is 3, which is a horizontal maximum at t equals negative 2. And then at x of this value here, 5, we go 1 minus 5, which is negative 4. That's going to be our lowest value, which is a horizontal minimum of negative 4 at t equals negative 2. Or sorry, t equals 5, pardon. All right, let's look at our vertical extrema now. So remember, vertical extrema, we're looking at t squared minus 1. So I know y of t equals t squared minus 1. So we're going to be looking at that, okay? So again, I know that my endpoints are negative 2 and 5. But remember, this looks pretty parabolic in shape. So if I were to sketch this out, I know it would look something like this, right? Well, I know here, now check it. I know here we've got our lowest value is right in the middle there at negative 1. It's not going to be where t is these, outside edges, okay? So when we're looking, we're not going to just look at the end points of the interval. We're also going to look at the sketch. You're also going to look at the endpoints of the interval and the sketch, because sometimes the type of sketch that it is, like for example, this parabola, I know that there's a minimum that's not on an endpoint. So let's look at a couple of values. If I look at my endpoint of t is negative 2, so I can look at y at negative 2. Let's evaluate it and look at those values. So I know negative 2 squared is 4, minus 1 is 3. I also know the other value, the other endpoint of t is 5. So if I evaluate y of 5, we get 5 squared is 25, minus 1 is 24. But I also know, hey, here at t equals 0, let's see what's happening there. So if I plug in 0, I'm going to get 0 squared minus 1. That's negative 1. So this is a clear winner for the minimum. So we can say there's a vertical minimum of -1 at t equals 0. And then we also have a pretty clear maximum here of a vertical maximum of 24, and that's when t equals 5. All right, so let's kind of compare our results from number 2 and look at the actual sketch, okay? So if you look at your graph on the other side or look on the screen, we can see here that as we go from when we have a horizontal max at t equals -2, so remember that horizontal max at t equals -2 gave me a value of actually when x is 3, so when we see x is 3, we see this endpoint here, okay? That's our horizontal max for sure. And we have a horizontal minimum when x is, or when t is -4, or when x is -4 and t is 5. So when x is -4, we see it up, over and up, we see it right here. This is our horizontal minimum. So remember, horizontal is left to right, minimum, maximum, left to right. And then as we're looking at our vertical, we saw here, hey, there was a vertical max of 24 when t equals 5. Well, that vertical max is also here. That's our highest point vertically. And then we see our lowest point vertically here, and that agrees with our minimum of -1 here as well. So like when we're looking at parametric equations, we're not just looking at the height. We're looking at a vertical max, a vertical min, a horizontal max, and a horizontal min as well. All right, let's look at some examples with no domain restrictions or endpoints, okay? So when I'm looking at this, I have to remember, how do I determine if it has a horizontal extrema or if it does? So if I look at x of t, I know that's here at t minus 1. Well, I know that's, if I were to just sketch that, it's pretty linear and it goes on forever. So there's no extreme because there's no ending. So we say that this is no extrema. And then also here, when I'm looking at the vertical, that's y of t equals t over 2 plus 1. It would look something like this. Okay, again, this is going to go forever with no restriction. Again, this is no extrema. Okay, so if I'm looking at this, I'm going to graph what this looks like. I'm going to use my calculator. Okay, I'm going to plug these in for x of t and y of t. So let's go ahead and do that. Let me pull up my calc. Go ahead and get yours out as well. Y equals, but I'm going to plug in t of -1 for my x of t. So t minus 1. Whoops. There it goes, t minus 1. And then my y value is t over 2. So we're going to go t divided by 2, all plus 1. Okay, and if you want to be careful, want to be sure, you can insert a parentheses around that t over 2. Go ahead and graph it. And we see here that we do have, and actually on my t step, I didn't want to have any endpoints here. So I'm going to have, whoopsie, I'm going to have my endpoints go pretty big. We're going to go to like -20 to +20 because I don't want it to graph anything with restriction. So we see something that looks like this that we can sketch on the graph. Okay. Let's look at number 4. It says f of t, so the horizontal extrema, again, we're looking at t plus 3, okay? But in addition to that, we also want to look to see, okay, even though there's no restriction, there is a natural restriction because we're talking both about t's here, even though this t has no restriction, this t here does have a restriction because it's inside of a root. So anytime I see that, I say, okay, wait, hold up. I know that this, whatever's inside that root, t plus 1 has to be greater than or equal to 0 because it's in the root, which naturally solves for t is greater than or equal to 1. This tells me my lowest value of t, even though I don't have a restriction on it, because of this, it would be undefined if it was anything less than 1. So I know my starting value has to be, oh, sorry, this is a -1 because if I moved it over, it's -1. That starting value has to be -1. So let's see what happens there at x of -1 because that's a natural restriction. So if I go -1, which is t plus 3, we get +2, okay? And we can say, okay, is this a minimum or is this a maximum? Well, I know because as I'm adding those values of t and I'm getting bigger, I'm not getting smaller, I know this is the smallest value because I'm only going to be adding those values because of this here. This tells me that this is a minimum, okay? Because as we add on to t, it's just going to get bigger. So if I look for this, so we know our vertical extrema, we can also look at that end point. Let's look at to see what happens at y equals -1. If I plug it in, I get the root of -1 plus 1 is just 0, okay? And we know that 0 is going to be the lowest value we can go because we can't get any lower on that t value. So we know that this is a vertical minimum of 0 at t equals -1, okay? So if I go to sketch that, I'm going to put this in my y equals, okay? Let's clear this out. And we're going to say t plus 3 and the x and the root of t plus 1 in the y. Notice that t plus 1 is in the root. That's what I want. I'm going to go ahead and graph it. And we see that it looks like a square root function. It's starting at 2, 0, and it goes up and to the right like that. Okay, so let's kind of wrap this up. We're going to talk about intercepts and x-intercepts and y-intercepts of parametric functions. Very similar to x and y-intercepts, really of any graph. So let's just kind of visualize a graph that looks kind of like, maybe it looks like this, okay? So if I'm looking at this, I see two things here. I see this point. I don't know exactly what x is, but I know it's x, 0 because it's on the x-axis, right? And same thing here. I see this point is the y-intercept because I don't know what y is right now yet, but I know x is 0 and y is some value. So this is where those x and y intercepts are located, right? On the x-axis is your x-intercept. On the y-axis is your y-intercept. Well, we know that x of t, the x-intercept occurs when actually the value for y is 0, and the y-intercept occurs actually when the value for x equals 0. We see this here. So the x-intercept happens, again, this is the x-intercept. Well, what's the y value? It's 0. At the y-intercept, we see the value of x here. What's the x value? It's 0. So it's kind of counterintuitive, but the x-intercept happens when y equals 0, and the y-intercept happens when the x equals 0. So let's go ahead and use that knowledge and find some x and y-intercepts. So we're going to find the x and y-intercept of f of t. Here's your x of t, and here's your y of t, okay? So again, to find my x-intercept, we're going to set that y of t equals to 0. So y of t is t plus 4. Set it equal to 0. Solve. We get t equals -4. So this tells me, hey, the x-intercept is happening when t equals -4. It doesn't tell me where it's happening. It just tells me when it's happening. So to find where it's happening, let's go ahead and plug in that t of -4. And we're going to set this equal to, now remember, we're going to plug this into t squared, which is -4 squared, plus 5 times -4 plus 6, okay? So this becomes -16 minus 20 plus 6 is a total of 2. And if for the y value, that t is -4 plus 4, and we end up with 0. So when t is -4, the value of our x-intercept is 2, 0. Let's look for the y-intercept now. So remember, for the y-intercept, we're going to set the x of t equal to 0, which means t squared plus 5t plus 6 equals 0. Let's go ahead and solve that. We know factoring here, we're going to go 6 on top, 5 on the bottom. What two numbers multiply to 6 add to 5? They've got to be 2 and 3. Use factoring, we get t plus 2 and t plus 3. Solve this by the zero product property. We get t equals -2 and t equals -3. So remember, this doesn't tell me what the y-intercepts are. It tells me where the y-intercepts are because, or I should say when. When, okay? So when t equals -2 and when t equals -3, we have y-intercepts. So let's evaluate that. What's f of -2? Well, again, we're going to plug that into here for x comma y. So we've got positive 2 squared plus 5 times 2 plus 6 comma -2 plus 4. So if I simplify that, we get 0 comma 2. And if I do this again here, where I'm looking for f of -3, we're going to end up with -3 squared plus 5 times -3 plus 6. Okay, that's our first part. And the second part is t, which is -3 plus 4. When I go ahead and check, crunch all those numbers, we end up with 0 comma 1. Okay, so those are my two y-intercepts, and I have one x-intercept. If I want to check this, I can absolutely graph this in my my graphing calculator, and it'll show you that we've got one x-intercept and two y-intercepts. I invite you to go and try that on your own. All right, that's it for now. Thanks.